is part one of a two-part series on a new offshore boat design, which is a 40-foot hybrid cat-ketch. It's hybrid between a monohull and catamaran, and is designed as a passagemaker in steel. The sketch in profile shows the basic elements of the design, and then here's the preliminary layout of the interior. There's a 14-foot beam with standing headroom on one level over 34 feet, so there's quite a bit of possibilities on interior layout design. This is just one example. The design criteria are listed here, and I'll go over each one separately in some detail. First, the boat was designed to be strong. It's all steel in construction, has collision bulkheads in the bow and forward portions of both hulls. There are no holes going through the boat. It's designed to be simple and easy to use, easy to sail. It's a catch-head rig with wishbones and roller furling on carbon fiber stainless masts. It's capable of being sailed short-handed. There are just two sheets for the rig, which lead to electric winches, which can be remote controlled from both the central cockpit and the interior steering station. It's designed to have accommodation and storage for two couples. There are two private staterooms with double beds, and it has 3 pilot berths. Of course, it can be used to live aboard in a marina. The beam is 14 feet, and it only has just over 4-foot draft. It does have designed to have diesel hot air central heating. There's no underwater holes in the vessel. The toilets are composting toilets, and it has gray water holding tanks. All underwater transducers are externally mounted. The vessel is powered by 2 outboard engines mounted on the transom. Part of the design ideas were to avoid complex systems, so it does have this simple rig. Other rigs, of course, can be used. It's capable of taking a 90-degree knockdown within uprighting. It has the same uprighting moment at a 90-degree knockdown as an equivalent monohull offshore vessel. It takes advantage of monohull and catamaran good features. The lead ballast is distributed at the bottom of both hulls, mostly amidships. It has minimal wetted surface area, especially when she's heeled. It minimizes the disadvantages of the 2 hull types. Each hull can be asymmetric in cross-section, aerodynamic for hydrodynamic lift when sailing to windward with airfoils. It's efficient when it's heeled. The wetted surface area reduces as the windward hull lifts. And it's not stable if it's capsized. It will upright on its own. It certainly has adequate fuel and other storage for passage making. There's just huge volume for tankage and storage in both the hulls. Well, thanks for your interest in viewing this part 1, and part 2 has a design model that goes into detail on the design features.